Physical reality is messy, irreversible, and unpredictable. But for centuries, mathematicians have sought ways to tame that chaos. They take the raw, tumbling randomness of a physical event, like flipping a coin, and smooth it into a clean, predictable probability distribution. Modern macroeconomic theory attempts to map human behavior and the arc of historical time. Yet its mathematical architecture is designed to eliminate the very human agency and historical progression it claims to study. To solve the equations of supply, demand, and growth, economists have constructed a deterministic system. They have built a rigid economic automaton. In psychoanalytic theory, Jacques Lacan uses the term touché to describe an encounter with the real. Tuché is the genuine accident. It is the shock that shatters structural expectations and cannot be predicted by any model. The automaton converts the future, which is technically incalculable, into a manageable sequence. Its primary function is the foreclosure of Tuché. By retrofitting reality into a closed loop, the discipline has created a world where true uncertainty is replaced by calculable numbers. This chart shows the mathematical environment of deterministic models, a phase space. The bounded curve represents all possible states. Any starting point's path is locked in by rigid equations. On the corresponding timeline, time is reduced to a sequence, mapping every future state in advance. Actual historical time is path-dependent. The decisions made today permanently alter the landscape of tomorrow, making it impossible to pre-calculate the destination. Inside this phase space, the future is a spatialized version of the present. There are no spontaneous events. There are only predetermined coordinates waiting to be reached. In computer science, an automaton is a universal machine that strictly executes the instructions of a specific algorithm. A finite state automaton operates by moving from a start state through intermediate states based entirely on coded inputs. It reads a symbol, like a 0 or a 1, and follows a rigid rule to transition to the next node. This movement is governed by a next state function. The machine maps its current state and input directly into a guaranteed future state. Lacking spontaneity, it remains frozen unless it receives a stimulus it was programmed to recognize. An automaton cannot mimic free will. It only processes the specific inputs it was pre-designed to recognize. Therefore, an automaton cannot experience an organic historical event. Its entire future is already contained within its initial rules. Orthodox economists faced a specific problem: how to model an infinite horizon of future decisions without the equations spiraling into impossible complexity. Their solution was recursive macroeconomics. This method takes past information and compresses it into a small, finite-dimensional vector of state variables. The structure of the computer science automaton maps onto the primary equations of recursive macroeconomic theory. The current state of the economy, x sub t, and random external shocks, u sub t, feed into a time-invariant policy function, g. Together, they generate the exact future state, x sub t plus 1. This creates a Markov perfect equilibrium. It is a closed loop where the optimization decisions of millions of agents reproduce the aggregate laws of motion that the model dictates. To make the math work, economists leave the social realm and enter the physico-mathematical universe. Recursive macroeconomics turns the global economy into a self-moving ahistorical automaton. It is a machine that processes economic shocks without ever altering its fundamental programming. If this macroeconomic system is a completely closed loop, how does it mathematically justify its handling of an unseen future? The framework relies on the ergodic hypothesis. This is an assumption borrowed from 19th century physics to simplify the behavior of moving particles. Ergodicity assumes that the average of all possible states of a system across space will inevitably equal the average of its realizations over time. Paul Samuelson used a physical metaphor. If you release a pendulum from various angles, its early paths look chaotic, but regardless of the initial release, it decays to the same point of rest at the bottom. The long-run outcome is independent of where it started. In a non-ergodic complex system, a tiny initial disturbance permanently alters the long-term trajectory. The system never returns to its starting point. By installing the ergodic axiom into the foundation of their models, economists guarantee that the past will always reveal the future. They blind the automaton to the possibility of structural change. What the macroeconomic automaton is capable of handling is aleatory risk. These are the random chance events that are numerically measurable as stationary, homogeneous series. Aleatory risk treats the unknown future as a game of chance with knowable odds. Individual spins of the roulette wheel are unpredictable, but over time they conform to a rigid probability distribution. The automaton treats the future of the global economy like this roulette table. It assumes all future recessions are draws from a known, stable urn. But actual history is driven by epistemic uncertainty, unique events for which no historical reference class exists. This is Tuché. The encounter with the real is the genuine accident that cannot be calculated or plotted on a bell curve. Structural crises and historical breaks are not simply missing from these models. The mathematical architecture itself is built to deny that an event without a past parallel can exist. The mathematical elegance of recursive competitive equilibrium frameworks is undeniable, but the cost of this perfection is severe. To solve the equations, time itself must be frozen and spatialized. Agents must be rendered static. When confronted with the messy, path-dependent reality of actual history, this rigid theoretical architecture fractures. The equilibrium calculated by these models is not a real destination in historical time. It is an ideal cognitive product, a dream of the marginalist revolution. The modern macroeconomic automaton is a triumph of pure logic. It secures a predictable future by